record na natin. Okay, for the objective, at the end of this session, you will be able to get the derivatives of trigonometric functions, exponential and logarithmic functions, inverse trigonometric functions, and hyperbolic functions. So dapat aware din kayo before, di ba, hindi naman tayo lang magde-derive. So, may mga algebra din tayo before na na-discuss na din naman natin yung mga trigonometry na to, exponential natin, yung mga inverse trigonometry, at saka yung hyperbolic. So, yung mga na-discuss sa inyo before na mga previous nyong professors, dapat make sure lang na naaalala nyo pa din. Like, for example, ano ba yung equivalent ni sine or equivalent ni tangent? Ganun siya. So, dapat aware pa din tayo. Okay. For this topic, we have 4 topics. So first is the derivative of the trigonometric function. Next is the derivative of the exponential and logarithm function, derivatives of the inverse trigonometric functions, and the derivative of the hyperbolic function. For the derivative of the trigonometric function, so pakita ko lang dito, yung first natin is we have yung i-consider natin yung mismong graph. So, ang graph na pinapakita natin dito is yung function ni y na we have the sine theta. So, pagbabasahin natin siya, yung theta natin. So, itong x natin, itong line na to, is nagsiserve siya as yung theta natin, itong part na to. And ito yung y natin na line. So, dito sa y na line, we have yung middle is yung 0 natin. Yung itong part na to is yung negative 1 natin. And itong part na to is yung, itong part na to is yung positive 1 natin. And itong part na to is yung negative 1 natin. And we have yung theta natin, which is itong part na to is yung negative pi over 2, negative pi, and so on. And for the side naman na ito, we have the positive side, we have the pi over 2 and the pi. So, kapag i-read natin, let's say, ang hinahanap natin is itong first natin, we have the theta of negative pi, and we have the slope of negative 1. So, saan daw siya? So, magpo-fall siya dito sa point na to. We have yung y, itong part na to, yung sa slope natin as yung sa negative 1, and we also have the negative pi. And next natin is we have yung negative pi daw as yung theta natin, and yung slope natin as 0. So we have here yung point na negative pi over 2, and nakatapat siya sa 0 natin. And for the next natin, we have yung 0 daw sa theta natin, and we have the 1 sa slope. So ito naman siya, itong point na to. And next natin is yung pi over 2 and 0. Ito naman yung point na to. And for the pi natin na theta, and we have the slope of negative 1, itong point na to. So, as a result, it is a resulting curve, cosine curve siya. Therefore, for the derivative, as shown here, we have the d over dx, kapag daw ang hinahanap natin is derivative of sine x, equivalent siya sa cosine x. Okay, yan yung shortcut niya. So, next naman natin is for the y. We have the y is equal to the cosine theta. So, same lang siya yung sa graph natin. Let's say, ang graph natin is we have the theta of negative pi, and yung slope natin is 0. So, ito yung point na yon. So, we have the negative pi and 0. And next naman daw natin, sabi natin, we have here the negative pi over 2, and yung slope natin is 1. So, itong point na to yun, positive 1. And yung 0, 0, itong middle natin, itong point na to. And for the pi over 2, yung theta natin, and negative 1 naman for the slope, itong point na to. And for the pi na theta, and for the 0 na slope, itong point na to. So, the resulting curve is a sine curve that has been reflected about the x-axis. So, yun na nga yan. Itong graph na to, ito yung pinapakita natin. Based dito sa theta, tsaka yung slope na given natin. Therefore, for the derivative or the d over the dx cosine x, we have the negative sine x. So, tatandaan niyo yun na ha. Kung ano yung sine x natin, pag derivative ng sine x ang hinahanap, equivalent siya sa cosine x. While for the derivative of cosine x, equivalent siya sa negative sine x. Okay, next natin. Ito is ano lang siya, long method siya na pinapakita. Pero ang equivalent lang niya is yung paano natin makukuha yung derivative ni tangent x. So paano siya nangyari? So dito, pinakita lang na ang base sa trigo or trigonometry natin, if kukunin natin yung derivative daw ni tangent x, we have here the d over dx kasi equivalent daw ng tangent is sine over cosine. So we have here the sine x over the cosine x. And since we have here yung quotient rule, pwede natin gamitin yung derivation ng quotient rule natin. So recall nyo lang din kung ano yung equivalent natin ng quotient rule. Sa quotient rule, we need to determine ano ba yung value ni u at saka ano yung value ni v. So ito yung sin x natin as yung u natin and yung v natin is yung cosine x. Sa mismong formula natin, we need to know yung v and then derivative ni u minus ni u, derivative ni v over ng v squared natin. So dito, we have yung cosine x times yung cosine x natin which is yung derivative ng sin x natin minus ng sin x natin and yung derivative ng cosine x natin over yung v squared natin which is yung cosine squared. And then, isi-simplify lang natin itong equation na to, which is pinagsama lang natin si cosine x, which is equivalent sa cosine squared x, and pinagsama lang natin si negative sine x at negative sine x, which is equivalent sa sine squared x. And yung denominator natin na cosine squared x. Therefore, we have here na cosine squared x plus sine squared x over the cosine squared x. And balik lang tayo dun sa trigonometric identity natin. Recall lang natin dun sa trigo natin. Diba meron tayo dong rule na if we have the sine squared x plus the cosine squared x, equivalent siya sa value ni 1. Ayan, itong rule na to. Therefore, dun sa kasunod nito, equation natin, we have the 1 over the cosine squared x. And sabi natin, kapag we have the 1 over cosine, is equivalent siya sa secant. So for this problem, since we already have cosine squared x, equivalent siya sa secant squared. Therefore, ang derivative ni tangent x is equivalent sa secant squared x. So, ito yung mga other formulas natin for getting the derivative based dun sa mga trigonometric function natin. Let's say, yung first natin kanina is we have the sine. For the derivative of the sine, we have the cosine x. For the derivative of cosine x, we have the negative sine x. For the derivative of tangent x, we have the secant squared x. For the derivative naman, ito is yung additional na natin. For the derivative of cotangent x, we have the negative cosecant squared x. For the secant x, we have the secant x times tangent x. And for the derivative of cosecant x, we have the negative cosecant x times the cotangent x. So, itong lahat ng formulas na to, kailangan yung ma-recall and ito is gagamitin natin sa lahat ng mga possible problems natin. So, kung before, ang mga discussion lang natin is based sa mga power rule, quotient rule, product rule, and other rules. So dito is focus tayo sa mga application na ng mga trigonometric function natin. So lahat siya is merong equivalent na derivation. Okay. So next natin, we have here naman na yung example kung paano natin siya gagamitin. So dito, for the example problem number 1, ang problem daw natin is we need to differentiate the g of x is equal to 3 secant x minus the 10 cotangent x. So, babalik tayo doon sa mismong mga formulas natin. Balik lang tayo. So, dito is, we have the secant and we have the cotangent. Kung babalikan natin yung formula natin, as shown here, we have yung equivalent natin ng secant x is gagamitin natin siya kapag dinerive na natin is we have the secant x tangent x. And for the next natin, for the cotangent naman, sabi natin, for the cotangent rule, we have naman yung derivation of the cotangent x is equivalent sa negative cosecant squared x. So, application nitong dalawang formula natin, which is yung cotangent is negative cosecant squared x and yung secant x natin, which is equivalent sa secant x tangent x. Okay, so for the application, we have here the first derivative or g prime x, we have here equivalent lang din to sa first derivative. Application, for the 3 secant x, we have the 3 secant x tangent x kasi yun na derivation natin. And for the 10 cotangent x, we have the 10 times dun sa negative cosecant squared x. So therefore, for the first derivative of this problem, we have 3 secant x tangent x plus 10 cosecant squared x. Dito sa next problem natin, given natin is y is equal to 5 sin x cosine x plus 4 cosecant x. So, babalik lang tayo dun sa formula natin. Pero for this problem, we need to use the product rule kasi we have yung problem dito na 5 sin x cosine x. And after nun, need din natin gamitin yung sa sum rule naman kasi since we have here naman yung i-add natin na 4 cosecant x. So for the product rule, again, recall lang, nilagay ko na rin dito yung formula para medyo hindi kayo maguluhan. So we have here yung derivative ng uv. So either dito, kung alin yung madedetermine nyo na u at yung v natin. And then next is yung u natin, ika-copy, and then kukunin natin yung derivative ni v plus yung v natin, and kukunin natin yung derivative ni u. And then after nun, after natin makuha yung product rule ng 5 sin x cosine x, kukunin naman natin yung derivation ni 4 cosecant x. Considered na yan doon. So, therefore, after natin na application nito, we have yung 5 cosine x cosine x plus sin x minus ng sin x. So, yung ito is derivation lang from dun sa cosine x natin. And yung cosine x is derivation from the sin x natin. Since ang formula natin is we need to derive yung v and we need also to derive yung u. For this naman, yung cosine x natin is kinapi lang siya and also for the sin x. Kasi we have yung u at yung v here. And for the derivation ng 4 cosecant x, we have the negative 4 cosecant x cotangent x. Therefore, ang first derivative natin for this problem is we have the 5 cosine squared x minus the 5 sine squared x minus 4 cosecant x cotangent x. So, ito na yung buong formula na, solution natin for the first derivative. For the next problem naman, so for the next problem, we need to use the quotient rule. For here, we have the differentiate p of t is equal to sine t over the 3 minus 2 cosine t. Okay, for the recall lang ng problem natin, we have yung numerator as yung u. And for the denominator natin, ito yung v natin. And application lang ng quotient rule. For the quotient rule, daw, ang formula is we have yung v multiplied dun sa derivative ni u, which is yung numerator natin, minus yung u natin, and i-multiply siya sa derivative natin na denominator, which is yung v natin, all over v squared. Okay. For this problem, ang v natin is 3 minus 2 cosine t. And kukunin natin yung derivation ng numerator natin. Ang numerator natin is sin t. So, ang derivation ng sin t is cosine t minus ng u natin, which is sin t, and derivation ng denominator natin, which is, kung meron tayong constant lang na value, which is 3, equivalent lang siya sa 0, so cancel na siya. And for the negative 2 cosine t is equivalent lang siya sa 2 sin t. So, we have here the 2 sin t over ng v squared natin, which is we have the 3 minus 2 cosine t squared. And isi-simplify lang natin yung problem, itong solution natin na to, we have yung 3 cosine t minus 2 cosine squared t minus 2 sine squared t. So, ito is inad lang siya, and itong cosine t na to is minultiply lang siya sa 3 and sa negative 2 cosine t, all over the denominator of 3 minus 2 cosine t squared. For the continuation lang, since hindi pa naman tapos yung problem natin, ito na siya. Isi-simplify lang natin yung problem natin. So, again, if we have the cosine squared t plus the sine squared t sa trigo natin is equivalent lang to sa 1. So, kung mapapansin nyo, dito sa next natin is wala na siya. Kasi 2 times 1 is equivalent lang siya sa 2. Therefore, ang first derivation natin is we have the 3 cosine t minus t over the 3 minus cosine t squared. So, ito na yung answer natin for the first problem. Yan. Okay, for this naman, so inverse na siya ng trigo. Let's say we have here na yon. So we have yung f of x or yung function of x natin is equivalent daw sa x squared. So pag nag-derive tayo ng value namin included sa x, so we have naman dito yung power rule natin. So equivalent lang siya dun sa rule natin ng power rule, which is we need to use this, yung n natin is yung 2, so we have here yung 2, and then x, and then raise dun sa n minus 1. Since yung 2 is minus 1, so equivalent lang siya sa 1. So we have the derivation of 2x. Okay? For next natin is example lang siya at x2. What if yung value natin here is papalitan natin yung x as 2? So 2 times 2 for this f of x is we have the 4, or 2 squared is equivalent to 4. And for the first derivation, pinalitan lang natin yung value ni x. So 2 times 2 is equivalent to 4 pa din. Since inverse siya, kailangan natin dito is mag-switch ng value. So let's say ang equation natin is we have the y is equal to x squared. So magiging x is equal to y squared, or also equivalent lang siya sa square root ni x is equal to y. Or we also have here yung y is equal to square root of x, na yung f raised to negative natin or yung inverse natin is equivalent sa square root of x. Yung y dito and yung f raised to negative 1 of x is also the same lang siya, itong value. And kapag graph natin siya, so ito yung example ng magiging graph natin. So itong line na to is for the y is equal to square root of x, and ito yung value for the m natin. And itong isang line naman na to is for the y is equal to x squared. So later, ipapakita natin yung shortcut for the arc or for the inverse trigonometric. Let's say, yung kanina naman is meron tayong mga formula for the derivation of trigonometric. We also have din yung formula for the inverse trigonometric. Okay, for this problem, sabi daw, is to find the derivative of the inverse function. So for the inverse function, we have here the function of f raised to negative 1 of x, f of x, yes, is equal to x raised to 1 half. 1 half. So yung first derivative lang dito is gagamit lang tayo ng power rule. So ito yung value ni n. So we have yung ito, nilagay ko na rin naman dito yung mismong formula niya. The derivative of x raised to n is equivalent to n x raised to n minus 1. So we have here yung 1 half. So copy lang siya as yung n. And x, so 1 minus 1 half is 1 half minus ng 1 is equivalent to negative 1 half. So therefore, we have yung first derivative for this problem is equivalent sa 1 over 2 square root of x. Okay. And then, next naman natin dito is if we have the f of x is equal to x squared lang din, yung same lang din siya sa kanina. And we also have yung first derivative as 2x at point, at x natin is 2. So substitution lang siya. Same lang din sa problem natin. So substitute lang natin yung value ng 2 sa mismong formula. So we have here for the slope reciprocal, pinakita lang siya dito. At 0.24, we have here, ito yung point na to. And for the 0.42, we have yung m is yung sa slope natin as 4, and we also have yung m as 1/4. And for the line again, itong line na to is for the x squared. And for this line naman is we have yung y is equal to the square root of x. And for this naman, we have yung sa f raised to negative 1 of 4, we have yung square root of 4 is equivalent lang siya sa 2. And kapag yung value natin as yung 4 naman, yung papalitan natin value is we have the 1 over 2 square root of 4. Equivalent lang siya sa 1/4, which is nakita na natin dito sa graph na to. Pinakita na siya sa graph. Ayan. Okay, same lang din to din sa kanina. Ayan. Dito naman is for the typical problem. Typical problem using this formula. So, for example, ito siya. So, we have the given as yung f of 3 natin is equal to 5. And we have yung given natin na d of f. Ayan, so we have here naman yung df over dx natin, which is yung 3 is equivalent sa 6. So, equivalent lang, yung hahanapin lang natin value is we have yung d of f raised to negative 1 over dx is equivalent sa 5. So, dito is yung value lang natin. So, inverse lang siya. We have yung value natin as 1 over 6 lang siya. So, inverse lang nitong value na to. And then, dito lang naman is pinapakita naman yung mismong implicit differentiation. So, inverse na daw siya. Kung kanina, ang sinasolve natin is yung sin x. Dito naman is we have yung sin raised to negative 1. Pag may raised to negative 1, is equivalent lang to dun sa inverse na hinahanap natin. So, we have here the y is equal to sin raised to negative 1x. Equivalent lang siya sa sin y is equal to x. So, same lang siya dun sa sinolve natin kanina where we have yung x tsaka yung y natin. So, kunin natin yung derivative daw ni sin y and yung derivative ni x. So, sabi natin, ang equivalent ni sin y is cosine y. And kapag nag-derive tayo ng value na may x, is equivalent lang siya sa 1. And application lang ng cross multiplication ito. So, we have the dy over dx is equivalent sa 1 over cosine y. So, ito is napunta lang siya sa denominator. And kapag titignan natin yung graph, we have here kapag y daw, kapag y is sin x, ito yung nature ng graph niya, yung color blue. While for the inverse naman, which is yung y is equal to sin raised to negative 1x, ito naman siya, yung red. Yan. So, ito yung graph natin. So, yun yung difference between dun sa sign lang natin and yung inverse natin na sign. Okay, for this problem naman daw, pinakita lang siya yung other way. So, dito is yung pinaka, kasi meron tayong shortcut lang. So, continuation lang for the problem kanina. Sabi natin kanina is yung dy, if we will going to get yung value ni y is equal to sin raised to negative 1x, which is nakuha natin dun sa graph is we have the dy over dx is equivalent sa 1 over the cosine y. So, application lang din dito nung sa additional natin for the formula natin. So, sabi natin kasi, di ba, kanina, is yung sa trigonometric natin, we have the sine squared y plus cosine squared y is equal sa 1. Ito. So, kung kukunin natin yung value ni cosine squared daw, ni cosine squared y, based dito sa formula natin na to, equivalent lang siya sa 1 minus the sine squared y. So, transfer lang natin itong sine squared y natin sa other side. That's why we have the 1 minus sine squared y. And then, para makuha natin si cosine y, square root lang natin both side. Kapag yung square root natin si cosine squared, so wala na siya. So, dito na sa kabila. Ayan, cosine squared. So, we have here the 1 plus minus the square root of 1 minus sine squared y. So, equivalent lang siya. So, therefore, if we have the cosine y, kung positive daw siya, we have yung 1 square root of 1 minus sine squared y. So, same lang siya. Therefore, yung formula natin for this problem is equivalent lang siya sa dy over dx is equal to 1 over the square root of 1 minus sine squared y, or equivalent siya sa 1 over the square root of 1 minus x squared. So, yung x squared natin na to is dito lang siya. Itong part lang na to. So, same lang yung formula natin. So, ito yung magiging formula natin for the inverse ng sin x natin. We have itong formula na to. And then for the additional formulas lang, ayan, so for the technique, para mas mabilis natin makuha yung value natin, so same technique lang din siya dun sa mga discuss natin kanina, which is yung pagkuha ng sign natin. Pwede rin natin makuha yung derivative natin ng tangent raised to negative 1 or yung arc sign natin, arctangent, or yung inverse natin. So same lang siya, iba-iba lang yung pagtawag sa kanya. So we have here the tangent raised to negative x and the derivative of secant raised to negative 1x. Okay. So for the shortcut, ito na yung mga formulas natin. Kung kukuhanin natin yung arc sign natin or the sine raised to negative 1u, we have the 1 over the square root of 1 minus u squared du over dx. For the inverse naman ng tangent natin, we have yung 1 over 1 plus u squared du over dx. For the inverse naman ng secant natin, we have the 1 over the absolute value of u multiplied by the square root of u squared minus 1 du over dx. And for the next naman natin na formula, ito yung other formulas natin. We have yung for the cosine or the inverse of the cosine, we have the negative 1 over the square root of 1 minus u squared du over dx. And for the cotangent raised to negative 1 or the inverse of the cotangent, we have the negative 1 over 1 plus u squared du over dx. And for the cosecant, or the inverse of the cosecant, we have the negative 1 over the absolute value times the square root of u squared minus 1 du over dx. And ito is same lang din naman sa kanya, pero naka application to ng pi. So we have the inverse for the cosine x is equivalent sa pi over 2 minus the inverse of sine x. And for the cotangent x, inverse of the cotangent x is equivalent to pi over 2 minus the inverse of the tangent x. And also we have the inverse for the cosecant, which is equivalent sa pi over 2 minus the inverse of secant x. So, for this problem, in-include ko na rin yung formula na pwede natin gamitin kasi ang first problem daw natin is we need to differentiate f of t is equal to 4 cosine raised to negative 1 t minus the 10 tangent raised to negative 1 t. So, an application, sabi natin, we need to know yung formula for the inverse ng cosine natin. And we also need to know yung formula for the inverse ng tangent natin, which is ito. Sabi natin, based on sa formula, we have yung d over dx ng cosine raised to negative u is equivalent sa negative 1 over the square root of 1 minus u squared. So, for this problem, ang application natin is hindi u. So, we have here yung t. So, application lang nung formula natin, we have yung constant value, which is yung 4 times nung 1 natin. Numerator natin is 4 over yung formula natin na 1 minus u squared, which is equivalent sa square root of 1 minus t squared. And for the negative 10 multiplied dun sa inverse tangent t natin, we have here yung formula natin as tangent raised to negative 1 u is equivalent sa 1 over 1 plus u squared du over dx. So, in application nito, ito na yung magiging derivation niya. So, we have the negative 10 as numerator and yung denominator natin is 1 minus t squared. Therefore, the first derivative for this equation is negative 4 over square root of 1 minus t squared minus 10 over 1 plus t squared. Second problem, we have yung y is equal to square root of z multiplied by the inverse. So we have here yung y is equal to the square root of z inverse of sine z. For this problem, gagamit tayo ng product rule kasi i-multiply or naka-multiply si square root of z kay inverse ng sine z. So for this formula, kapag gagamit tayo ng product rule, we have here yung derivative ng d over dx uv is equal to u, derivative ng v plus v derivative ng u. And for the inverse, ito daw yung formula natin. For the inverse of sine u is equal to 1 over the square root of 1 minus u squared du over dx. So, for this problem daw, ayun, so derivative niya, we have yung sa derivative natin ng first is yung square root of z. Itong square root of z is equivalent lang naman siya sa sa 1 half z natin. So kaya tayo dito we have yung 1 half z and then yung power rule natin, application ng power rule natin which is ito. And for the sine natin as is lang naman to, so sine z. And for the derivative, ito is naka-simplified na siya. And for the derivation ng sine z natin, ito siya. Yan. So we have the square root of z. Square root of z, ito na yung part nitong part na to. Itong may VDU na tayo. So as kung mapapansin nyo kasi we have the square root of z. Pero dito is we have yung 1 lang. That's why we have the square root of z over the square root of 1 minus z squared. So again, derivative for this problem, gumamit tayo ng power product rule. Kaya tayo nagkaroon ng derivation ng itong formula na to. Ganyan lang. So therefore, for the derivation or the first derivative of this problem, we have the 1 over 2 z raised to negative 1 half sine raised to negative 1 z plus the square root of z over the square root of 1 minus z squared. Tayo ng derivative of exponential and logarithmic function. So, dito sa problem naman natin is from dun sa mga previous natin na discussion, na-discuss na rin naman natin kung paano tayo gumamit ng limits. For this, we have naman daw yung example is we have yung graph y is equal to e raised to x. So, yung slope na pinapakita dito is at x. Ito siya, yung slope. So, for example, ito yung slope natin. And for the function lang, application ng function natin, which is we have yung sa limit approaching yung h natin, approaching to 0. And we have here the application of e raised to 0 plus h minus e raised to 0 over h is equivalent lang daw siya sa 1. So, yun siya. Gagamitin natin. So, kapag graph natin, ito yung graph niyan for the example natin. Let's say ito yung problem natin. We have the derivative. So, ano to long term. Kung paano lang siya, pinakita lang dito kung paano nakuha yung derivation. Pero, ang derivation lang natin is ito. Ito lang siya, itong part na to. So, application again ng limit where we have yung kukunin natin is yung d over dx ng e raised to x daw. Yun yung hinahanap natin. Application ng formula natin, we have the limit h approaching 0 equal siya sa e raised to x plus h minus e raised to x over the h natin. So, limit niya. So, pinaghiwalay lang dito. Yan. So, we have the limit of h approaching 0, e raised to x multiplied by e raised to h minus ng e raised to x natin over ng h natin. And then, next natin is multiply natin. So, base lang din dito. So, we have the e raised to x multiplied by the e raised to h minus 1 over nung h natin. So, same lang naman ito dito. Itong part na to. And we have here the e raised to x times the limit of h approaching to h approaching 0, we have the e raised to h minus 1 over the h. Pero ang assumption natin nito is equivalent siya sa 1. Therefore, we have the e raised to x times the 1. Kaya ang derivation natin, derivation of e raised to x is also equivalent sa e raised to x. Yun lang daw yung derivation niya. So kahit na sobrang haba nito, ang equivalent lang din ng derivation nito is e raised to x pa rin. So yun yung shortcut. Pag magdederive tayo ng exponential. So we have here the derivation of d over dx eu is equal to e raised to u du over dx. So yun nga yung equivalent na sinabi natin. Wherein we can use this formula to find the derivative of a raised to x. So sa next natin na yan. So we have here, we have yung formula as d over dx a raised to x, d over dx e raised to ln a raised to x, wherein we have the e raised to x and ln x are inverse function naman siya. So yan. And then we have also yung d over dx e raised to x ln x, and yung chain rule natin na e raised to x ln x times the d over dx x ln e. So chain rules. Chain rule is other discussion natin. And for the, sabi natin kanina, so pwede natin makuha for the ax yung sa based dun sa exponential natin. So we have here for the d over the dx ng a raised to x, we have the e raised to x ln a multiplied by the ln a. So we have here naman constant naman siya. So ang formula natin for the derivation is we have the a raised to u ln a du over the dx. Yun lang siya. Ito yung formula. So therefore, we have here yung sa exponential natin, which is e raised to u. Equivalent lang siya sa eu du over dx. And yung a raised to u natin, which is equivalent sa a raised to u ln a du over dx. So, yan. Now, it is relatively easy to find the derivative of ln x. Okay, for the ln x naman natin, so or yung ln natin, pwede rin natin makuha yung derivation niya. So ito yung long na method natin, pero ang equivalent lang naman niya is we have the 1 over u or du over dx. Pinakita lang dito na yung y natin is equivalent sa ln x, where it is also equivalent here. We have the dy over dx is equal to 1 over the ey. Ito lang siya. Para makuha natin yung mismong formula natin for the ln, for the derivation of ln, which is equivalent again with 1 over u du over dx. Ayan. So, for the logarithm naman natin, logarithmic function, we have here naman yung kung paano natin nakuha yung derivation for d over dx log x. We have d over dx, multiplied lang siya dun sa ln x natin over the ln 10, which is equal also sa 1 over ln x, ln 10, d over dx ln x natin. Or equal din siya sa 1 over ln x, ln 10 times the 1 over x. Yung 1 over x natin, kung papansin nyo, ito lang siya, yung ln x natin. Pag hinanap yung ln x, equivalent lang siya sa 1 over x. So therefore, ang logarithm natin is, pagkuha tayo ng derivative, we have the 1 over u ln a du over dx. So ito yung formula for the logarithmic function. And therefore, we have here naman for the exponential and logarithm function derivation or yung derivatives natin. Again, we have d over dx for the exponential or the e raised to u. Equivalent niya is e raised to u du over dx. For the ln naman, we have the d over dx ln u. Equal daw siya sa 1 over u du over dx. For a naman, we have d over dx a raised to u, equal lang siya sa a raised to u ln a du over dx. And for the logarithm, we have the d over dx logarithm of u. We have the 1 over u ln a du over dx. And next na natin is yung application na ng mga formulas natin. First problem natin. So, para madali, naglagay ulit ako dito ng mga formula or application natin, no, based doon sa 4 categories natin sa problem. Okay, sabi natin, for the first problem, we need to differentiate r of w, where we have the 4 raised to w minus 5 log 9 w. Okay. For this problem, yung first natin, ito is for the AU, A raised to U. And for this naman is yung application ng logarithmic natin. Okay, logarithm natin. So, for the first is, we have yung 4W, ang first derivative niya is application nito. Therefore, we have the 4 raised to W ln 4. Yung A natin is yung 4. And for the negative 5 log 9W, application naman itong formula. Therefore, we have naman yung, dahil meron tayong 5 dito as constant, we have 5 sa numerator over the W ln 9, where yung A natin is yung 9. For the example number 2, we have the exponential and yung ln. So, we have here yung f of x is equal to e raised to x plus 10x, ano yung nakalagay? 10x raised to 3 ln x. Okay, for this problem, yung e is for exponential lang natin, which is itong formula na to. Well, for this problem is application ulit natin ng product rule kasi mag-multiply tayo. So, iba si 10x raised to 3 at iba si ln x natin. So, again, for the product rule, formula lang natin is kailangan natin alam si u at saka si v natin. Okay, for this 3e raised to x, equivalent lang siya sa 3e raised to x, since yun lang din naman yung problem natin. And for this naman, sabi natin, we have yung ln x, and then ito siya. And then derivation ng 10x raised to 3, which is 30x raised to 30x squared, application ng power rule, and plus nung 10x raised to 3 natin, and application nung for the ln natin, derivation ng ln x is 1 over x. Therefore, for this problem, ang first derivative natin is 3e raised to x plus 30x squared ln x plus 10x squared. Okay, for the problem number 5, kung yung mga previous problem natin is application ng product rule, for this naman is we have the quotient rule naman kasi we have the numerator and the denominator. Again, for the problem, we have the differentiate y is equal to 5 e raised to x over the 3 e raised to x plus 1. Again, for the formula for the quotient rule, we need to know yung u. U is the numerator, and for the denominator, we have the v. And then we need to write lang yung v and then multiplied by the derivative of u minus u multiplied dun sa derivative ni v over the v squared. Same lang to dun sa mga na compute natin ng application ng quotient rule kanina. So, ayan. So, we have yung v natin. Ito, we have the v 3e raised to x plus 1. And derivation ng exponent natin, same lang siya. 5 e raised to u is e raised to u. So we have the 5 e raised to x minus the value of u natin, which is 5 e raised to x. And derivation of the v, since we have the 1, constant value is equivalent sa 0. So we have here the 3 e raised to x. And for the denominator, we have the v squared daw, which is equivalent sa 3 e raised to x plus 1 raised to 2 natin. Yan. And simplify lang natin yung problem. So we have here the 15e raised to 2x plus 5e raised to x minus the 15e raised to 2x all over the denominator of 3e raised to x plus 1 plus 1. Ayan, squared na siya. And since yung problem natin is we have the positive 15e raised to itong part na to, 15e raised to 2x, and we also have the negative 15. So, pag pinag-add natin siya is equivalent na siya sa 0. So, ang simplified natin is we have the 5e raised to x over the e raised to x plus 1 squared na yung value niya. So, ito yung magiging first derivative natin for this problem. Ayan. So, dito, pinakita na natin lahat ng formula for the hyperbolic, which is we have 6 hyperbolic functions daw. Isa-isahin natin. So, kanina, diniscuss na natin yung trigonometric natin and yung inverse trigonometric natin. Dito is, meron pa rin tayong trigonometric, pero nasaan na siya? And you have the sin h x is equal to e raised to x minus the e raised to negative x over 2. And for the tangent naman natin, tangent hx, we have the sin hx over the cosine hx. And we also have the second hx is also equivalent lang siya sa 1 over the cosine hx. And for the cosine naman, cosine hx is equal to e raised to x plus e raised to x minus 2. So, kung mapapansin nyo, halos same lang yung formula nito, ni sine tsaka ni cosine. Ang pinagkaiba lang nila is dito is minus. And for the cosine is we have yung plus. And for the cotangent naman, cotangent hx, we have the cosine hx over the sine hx, or equivalent lang siya sa 1 over the tangent hx. And for the cosecant, we have the cosecant hx is equal sa 1 over the sine hx. Again, same lang dun sa previous natin na derivation. Itong formula na to is kailangan nyo pa rin siyang ma-recall sa lahat ng mga problems. Hindi nyo naman need na kabisaduhin, pero mas maganda pa rin na aware tayo sa lahat ng mga formulas. Okay? So, dito is pinapakita lang yung mismong graph or yung behavior natin, behavior ng bawat graph. So, we have here for the y is equal to cosine hx. So, ito daw yung itsura ng graph niya, parang letter U. Yan siya. While for the y is equal to sine hx, ito naman yung graph niya, itong part na to. And for the y is equal to tangent hx, ganito naman yung behavior ng graph niya. Yan. Okay, for this naman, yung facts naman na related sa hyperbolic function, we have the sin h multiplied by the negative sin x is equal lang siya sa negative sin hx. And for the cosine h squared x minus the cosine, the sine h squared x is equal lang siya sa 1. So parang ito lang din yung formula natin kanina na sine squared x minus cosine squared, cosine squared x, sine squared x is equal to 1. And for the cosine h negative x, we have cosine x lang siya. And for the tangent, 1 minus tangent h squared x is equal lang siya sa secant h squared x. So, yun yung mga formulas daw for the hyperbolic function. And for the derivative naman daw na application natin, we have here that for the exponential, we have d over dx e raised to x is equivalent sa negative e raised to negative x. And for the d over dx ng sine hx, so ito is yung kanina lang natin na formula, derivation lang ng e raised to x minus e raised to negative x over 2. Simplify lang natin. We have the e raised to x plus e raised to x over 2, which is also equivalent sa cosine hx natin. And for the derivation na kanina is yung mga functions pa lang. For this is paano na tayo magde-derive naman using the hyperbolic functions. Sabi natin, for the derivative of sine hx, we have the cosine hx. For the derivative of tangent hx is equal to secant h squared x. For the derivative of secant hx, we have the negative secant hx tangent hx. And for the cosine natin, derivative ng cosine hx is equal to sine hx. And for the cotangent hx, derivative nito is equivalent to negative cosecant h squared x. And for the cosecant, derivative of cosecant hx is equal to negative cosecant hx cotangent hx. Okay. Ayan na. For this problem, ayan. For this problem naman, sabi natin, for the first problem, differentiate f of x is equal to 2x raised to 5 cosine hx. Sabi natin, since iba si 2x raised to 5 kay cosine hx, we need to use again yung product rule natin. So, babalik na naman tayo din sa product rule natin. So, ito is application lang ng power rule natin. And for this one is yung hyperbolic natin. Sabi natin, balikan ulit natin yung kanina. For the cosine hx natin. For the cosine hx, kapag nag-derive tayo, ito, yan. For the cosine h, pag nag-derive tayo, derivation ng cosine hx natin is sine hx. So, ayan, gagamitin natin siya dito for the problem. Sabi natin, for the product rule, again, for the product rule, we have the copy lang natin to cosine hx and yung derivation natin for the 2x raised to 5, which is equivalent lang sa 10x raised to 4. So, paano nangyari yun? We have yung constant value as 2, tapos multiplied din sa n natin, which is yung 5, kaya tayo nagkaroon ng 10. And for the exponent, we have yung n minus 1 natin, which is yung n natin is yung 5 minus 1, kaya tayo nagkaroon ng x raised to 4. Yan. And for the next is i-add lang natin yung value natin ng 2x raised to 5 and yung derivation natin ng cosine hx, which is sine hx. Therefore, for the first derivative of this equation, we have 10x raised to 4 cosine hx plus 2x raised to 5 sine hx. Okay. Next natin na problem. For the next problem, application naman ng quotient rule. Sabi natin, differentiate h of t sine h is equal to sine ht over t plus 1. So, ito yung sine ht natin is yung u natin. And for the v is yung t minus, t plus 1, for the v. And for the formula again, for the quotient rule, we need to know yung v natin, v multiplied by the derivative ng u, tapos kunin natin minus dun sa u natin and yung derivative ng v natin, all over ng v squared. Again, for this problem, sabi natin, yung v muna natin. Yung v is t plus 1. Ito siya, yung t plus 1 natin. And for the derivative daw ng sin ht, equivalent lang siya sa cosine ht. Minus ng u natin, u is sin h natin, sin ht. And then for, parang kulang to Okay, okay lang pala. Okay, sin ht times nung sa value natin ng derivative daw nito ng t plus 1. So derivative ng t is equivalent sa 1. So wala na dito, hindi na nailagay yung 1. Pero 1 times the negative sin t is equivalent lang naman sa negative sin ht. And for the derivative ng 1 is equivalent lang siya sa 0. So for the denominator naman natin, we have yung v squared for the quotient rule. Therefore, we have here the t plus 1 and squared siya. Therefore, for the derivative of this problem, we have t plus 1 cosine ht minus sin ht over the open and close parenthesis of t plus 1 squared.